Okay. So here I'll explain once more, children. Two cells are connected in series. How will you understand they are in series? Negative, positive, negative, positive, like that the cells are connected. That combination is known as series combination. And what is the net EMF of this combination? That is what we have to find out. So when cells are connected in series, the net EMF is ES, series. S suffix means series. ES is equal to sum of the EMF, E1 plus E2. And when they are connected in series, we know the resistances, internal resistances of the cell are also connected in series. Therefore, effective resistance R is equal to R1 plus R2. So, if we know the total EMF and the total internal resistance, we can calculate current by Ohm's law. According to Ohm's law, V equal to IR. Therefore, I equal to V by R. V means total EMF, E1 plus E2 by current, by resistance. Resistance is R1 plus R2. So, total current that is given or we are getting from this combination will be E1 plus E2 divided by R1 plus R2. Next is cells connected in parallel. You can see the parallel combination. You can see the parallel combination here. Okay. Here for series combination we use for getting more voltage, and parallel combination we use mainly for getting more current. We use parallel combination, high current. For getting that we use parallel combination. And here, if the two cells are connected in parallel with the same EMF, children, the EMF of the combination will be same as that of the same cell, the same single cell. But here we use different EMF. For example, one is 3 volt, other is 6 volt, like that. Different EMFs are there. And this cell is having internal resistance 0.1 ohm. This one is having another value of internal resistance 0.2 ohm, like that. So, two cells we have taken, their EMFs are different and their internal resistance are also different. Okay, and they are connected in parallel. Parallel combination, how will you understand they are in parallel? Positives are connected together. Negatives of the battery or cell are connected together. This combination is known as parallel combination. All the positives are connected together. All the negatives are connected together. And then a terminal is taken from there. And here, the current main circuit, this will go to the, for example, if suppose we want to connect it to a battery or a circuit, we will connect Ohm's law circuit when we connected. Like that, any circuit can be connected here. So, how much current we get here? This will send a current through this. We know parallel combination, what is constant still and current or voltage? Parallel combination which is constant? Current or voltage? Voltage is constant. Okay. But current will be, the potential difference between these 2 points will be same. Potential difference. But current coming from this battery is different. Current coming from this battery is different. Why? Its EMF is E1, its resistance is R1. So, what is the current coming from this cell? Upper one. Krishna Prabha, what is the current coming from this cell?
Teacher.
What is the current coming from this cell? EMF E1, internal resistance R1. So, what is the current?
E1 by R.
E1 by R1, correct. Similarly, for this cell, it is EMF E2, internal resistance R2, current coming from this one. So, the I2, you can take I2 here, we can take I1 here. I1 is E1 by R1 and I2 is E2 by R2. So, total current will be sum of these two current I1 plus I2. That means E1 by R1 plus E2 by R2 will be the current coming through this part of the circuit. Here also that will current, total current, that is I1 plus I2 will come here. See, here it enters, negative terminal it enters, from the positive terminal it leaves. Like that you have to put the arrow mark. Always current leaves from the positive terminal and end at the negative terminal. Leaves from positive terminal, end at the negative terminal. Like that we have to draw the circle. Okay. And total current we can calculate E1 by R1 plus E2 by R2. Okay. You can see the equations. Okay, equations you see. Current coming from this is E1 by R1 and current coming from this is E2 by R2, and we are replacing these two cells with a single cell, and it is giving the same current we are getting here. Whatever current we are getting here, I is the current getting here. I is sum of I1 plus I2 or E1 by R1 plus E2 by R2. That is the current we are getting here. And if you connect it with a wire, the same current will flow through this wire. No external resistance is given. Here we have not connect short circuited. No external resistance. If we connect a resistance, the voltage will be different. Not it will be terminal potential difference. It will not be E1. It will be V itself. So here instead of these two cells, we connect a single cell. And how can you tell this is equivalent to this? If this cell is giving the same current through the circuit, we can tell, oh, this one is equal, this single cell is equivalent to these two cells because it is giving the same current as it is given by these two combination, parallel combination. By the parallel combination, how much current we are getting? The same current we are getting from this single cell. Then we can tell this is equivalent to this combination of these two cells. So this is the combination. Instead of these two combination, a single cell is taken. So its current, EP by RP. EP is the EMF of the combination cell and RP is the internal resistance of this single cell. Then current will be EP by RP. And we know the equivalent to this, we have taken a single one which is producing the same current as it is produced by these two individual cells. So EP by RP for this combination, we can write the current coming from this is EP by RP, and it is the sum of current coming from these two cells. So E1 by R1 plus E2 by R2. So we got the equation. RP, how will you find out, children, when two cells are connected in parallel? How will you find RP? 1 by RP equal to? Lakshmi Priya, 1 by RP equal to?
1 by R,
Uh,
1 by R2.
1 by R1 plus 1 by R2, or RP equal to R1 R2 by R1 plus R2. By that method, RP you can calculate. Okay. And for doing problems, these factors, everything you must know. Then only you can do the problems. So, knowing RP, we can calculate the EP also. We can calculate. See, from this equation, taking LCM and all, you can calculate that EP. Okay. So current, this is equation for current, EP by RP equal to E1 by R1 plus E2 by R2. So for parallel connection is used for getting more current. So if you want more current and more voltage, what will you do, children? You want more current and more voltage. More current, which connection select? More current? Parallel or series?
Parallel.
Parallel. Parallel. More current. More voltage, which one will you select? Series. If you want more current and more voltage, what will you do?
Parallel series combination.
Combination. You connect two cells in series and then another two cells in series, you connect them parallel, then you will get more voltage and more current. Combination, series, parallel, combination we can use. So we get more current and more voltage like that. Okay. Yes. So this is when, but you know, in the notebook you can see very lengthy derivation is there. Very lengthy derivation is there. This is a easy method to remember things. Understand? Easy method for doing problems and all. You can just remember this. But derivation, you know, derivation, it is very lengthy one. I will explain that to you from notebook. Okay. So I will take the notebook, children, and explain. Some more things we have to explain from the notes. Notes. Notes, this I cut because that carbon resistor last year deleted. I don't know. This year, I think, I hope sometimes that may be deleted. So that's why it is cut here. Actually, I prepared the note, later came to know that is not in the syllabus. This year, the deleted syllabus will come last of this month only. So we can delete now. If it is there, I will take that, children. Effect of temperature on resistance. That is very important factor. So that equation you have to study. What is resistance, children? Resistance. Resistance is, what is resistance? Somebody asks you, what is resistance? What is your answer?
The opposition force opposed cell to
Yes. See, that is about the cell I told you, internal resistance. Okay. And if it passes through a wire, what is resistance? If it passes
it
through
is a
a
property which resists
property to property to
resist
resist
the flow of
resist
the current.
resist the flow of current. Okay, it is the property to resist the flow of current. Okay, opposition to the flow of current, that is resistance. So in order to reduce resistance, we can use resistor connect. Resistor can be connected to reduce current. To reduce current, we connect resistance in the circuit. In series, when we connect a number of resistances in series in a circuit, current reduces too much. So resistance means opposition to the flow of current. And what is the purpose of resistance in a circuit? In a circuit, we connect resistance to reduce the current. But you know, there are some other effects also. Okay, depending on the temperature, what is happening to this resistance? Let us see that, very important. What happened to the resistance? Resistance we have studied according to Ohm's law, V equal to IR, R equal to rho L by A, all those equations we have studied. Rho equal to M by N E square tau. Do you remember? According to Ohm's law, V equal to IR, R equal to please tell, V by I, R equal to V by I. And we told R is a constant for a material. And at the time of defining Ohm's law, I told you, you have to specify the condition. What's the condition?
Constant.
Temperature is to be kept constant. So if temperature is varied, resistance will vary. That is what we are going to study now. Effect of temperature on resistance. If temperature is kept constant, resistance for a material is constant. But if temperature is varied, what happened to resistance? And there is an equation connecting that. See, you can consider a wire. A wire resistance wire is given. Resistance wire. Which are the resistance wires we usually take, children, in lab and all? I told that name once. Once or twice I told. Which wires we use as a resistance wire? Do you remember while explaining that Ohm's law? one silver colored wire. No, that is not silver. Do you remember that name?
Re.
Which one?
Nichrome.
That is not nichrome. That is constantan. Nichrome is also resistance wire. Okay, in that Ohm's law experiment and all, we use that is an alloy wire. Okay, alloy. That is a constantan, manganin. Such wires are used. Eureka, name of those wires. Such wires are used as resistance wires. And I will tell you later why such wires are used as resistance wires. That is coming after explaining this. I will tell you. Okay, why such wires are used as resistance? Copper wire. Can we use copper wire as resistance wire, children?
No.
No. Why?
Because it is good. It's a conductor.
It is a very good conductor. Very small resistance only it offer. It's a very good conductor. Conductivity is more, resistivity is
Less.
Conductance and resistance are inversely proportional. If it is a very good conductor, then what does it mean? What is the value of its resistance?
Very
less. Very less. Okay, very good conductor, but that means it is having very less resistance. No position of current, easy flow of current through the wire. That's the meaning. So here, effect of temperature on resistance. That is what we are going to study now. So for that, you have to consider a wire of resistance R1. And initially, you measure its temperature. You take a wire and note its temperature, T1. Then it is heated. Wire is heated. And we know when it is heated, resistance is varied. Metal, especially metals, resistance increases. So we are taking R2 is the resistance at a temperature T2. So when it is heated, we know temperature is more than the initial temperature. And temperature increases, and thereby its resistance is also found to increase in metals. And we are writing the equation that increase in resistance R2 minus R1. R1 is the initial resistance, R2 is the final resistance. That what is the increase in resistance? Final minus initial value. R2 minus R1 is proportional to what all factors? Children, increase in resistance depends upon, will it increase with increase in temperature? Resistance. See, resistance is mainly due to the collision of electrons with the ions of the conductor. So, when resistance increases, that collision becomes more frequent. Temperature increases, collision becomes more frequent. They collide very fast. That's what happening. Temperature increases, they get more energy and they will vibrate more faster and they will collide. Time of collision decreases. Time of collision decreases. So, in effect, what happened? Resistance is increasing with temperature. So, R2 minus R1 is directly proportional to temperature difference. For example, initially 10 degree heated to 50 degrees Celsius. The next case, initial 10 degree heated to 100 degrees Celsius. The difference in temperature is more. When difference in temperature is more, first one 0 to 50 only, difference 50. Second case, we have taken 0 to 100. Temperature difference is made 100 degrees Celsius. Then increase in resistance is also increased. When we increase the temperature difference, their resistance is also found to increase. So R2 minus R1 is directly proportional to T2 minus T1, temperature difference. R2 minus R1 is also proportional to that initial resistance also. Okay, these two factors depend. R2 minus R1 is directly proportional to R1 combining these two factors. R1 into T2 minus T1. R2 minus R1 equal to a constant alpha. This is alpha, temperature coefficient of resistance into R1 into T2 minus T1. Therefore, alpha equal to R2 minus R1 by R1 into T2 minus T1. Very, very important formula. Variation of resistance with temperature. Where alpha is known as temperature coefficient of resistance and its SI unit is R resistance unit cancel, denominator temperature unit only will be there. What is the unit of temperature in SI system? What is the unit of temperature in SI system? Children? Unit of temperature, Kelvin, Kelvin. So Kelvin raised to minus 1 because it is in the denominator. Kelvin raised to minus 1. So R2 minus 1, we have formula we got variation of resistance with temperature. R2 minus R1 equal to alpha into R1 into T2 minus T1. Therefore, alpha equal to that constant temperature coefficient of resistance alpha equal to R2 minus R1 by R1 into T2 minus T1. This equation is very, very important and you can see problems in textbook also, you can see problem. And here, what is the significance of studying alpha, temperature coefficient of resistance of a material? See, for metals, alpha is positive. That means R2 is always greater. For metals, when temperature increases, resistance is increased. So R2 is always greater than R1. R2 is always greater than R1. So this value becomes positive value. Understand? So alpha is positive. For metals, alpha is high positive value. And you know, for alloys, this value is a very small positive value. What's the meaning of that? Small positive value. Alpha is small positive value. What is the meaning? What about R2 minus R1 in that case? Small positive value. R2 minus R1, will it be more or will it be less?
Less.
It will be less. It will be less. That means a small difference only you can see. R2 minus R1, very small difference only you can see. Alpha is a small positive value means this difference is very small. That means on heating alloys, that it is not at all showing much difference in its resistance. That is the importance of this factor. Alpha is small positive value means even though we are heating it, its resistance is not changed much. Resistance change is not there, very small only. So such wires are used for making standard resistance wires. But that is why constantan, manganese, etc. are used as standard resistance wires. Alpha is very small positive value. There is no much increase in resistance when we increase the temperature. Understand, children? So why these alloys, constantan, manganese, etc. are used as standard resistance wires? Alpha is
A
small
small
positive value, small positive value. The one increase in the temperature resistance is not
changing.
not changing much, changing but not changing much. Okay, so that usually is a question asked from that part. Alpha positive, small positive value for alloys. Why standard resistance wires are made of such material having alpha small positive value? Temperature coefficient resistance alpha is defined as the change in resistance per unit original resistance per degree Celsius rise in temperature. That is the definition. See, definition for alpha. Increase in resistance. R2 minus R1 is increase in resistance per means divided. Increase in resistance per unit original resistance. So, R1 is unit original resistance. But this is also made unity. That means temperature difference. 1 degree Celsius rise in temperature or 1 Kelvin rise in temperature, unit. And this is made unity. R1 is made unity. Temperature difference is made unity. Alpha is the increase in resistance. So, alpha is the increase in resistance per unit original resistance per degree Celsius rise in temperature. Okay, that is the definition for alpha. Temperature coefficient of resistance alpha is defined as the change in resistance per unit original resistance per degree. Degree means unit itself, unit degree. 1 degree rise in temperature. Temperature coefficient of resistance alpha is highly positive for metals. High positive value means resistance is increased very much on heating. Resistance for metals on heating, that resistance is increased very much. Okay. Temperature coefficient of resistance alpha is high positive value for metals. For insulator and semiconductor, it is negative. So all the variation you should know very well. In metal, how it vary? In metals, temperature coefficient of resistance is high positive. Insulator and semiconductor, same behavior. Alpha is negative. But for some alloys like manganese, constant and eureka, the value of alpha is very small, small positive value. So all these variations are very important questions will ask. Okay. Semiconductors, how it vary? On increasing the temperature, resistance inversely proportional. On increasing the temperature, resistance, well, semiconductor
Decreases in semiconductor.
decreases. Yes. Metals, how it vary? On increasing temperature, resistance
Increases.
increases. Metals increases, insulators and semiconductors
Decreases.
decreases. But for alloys, increase, but it is
Not much.
not much. Yes. Small positive value. Alpha is small positive. High positive for which one?
Metals.
Metals. Negative for which one?
Semiconductor.
Semiconductor.